Imagine an AI company making a move that sounds more like a utility company than a software company. Not buying more GPUs, but securing the output of a power plant. If that feels extreme, it may be the clearest signal of where AI is going next. Not just into servers, but into infrastructure. Today, we'll use one case, Microsoft and Constellation Energy, to understand a bigger pattern. When AI scales, it doesn't just scale in chips, it scales in megawatts. So what exactly happened? Constellation announced it would launch the Crane Clean Energy Center at the former 3 Mile Island site, restoring a nuclear unit. Under the agreement, Microsoft would purchase energy to match the power its data centers use in the PJM grid with carbon-free energy. Microsoft described the deal as enabling the restart of an 835 megawatt nuclear facility, retired in 2019. Later, the US government backed the restart with a $1 billion loan, aiming for operations around 2027, pending approvals. Most people react, what does 835 megawatts actually mean? To answer that, we need 2 quick translations. A megawatt is the rate of power you can use at a moment. Think of it as the width of a power pipe. A gigawatt is 1,000 megawatts, a different scale of power delivery. And the grid is the delivery system. Wires, substations, permits, and capacity. It's not a slogan. It shows up as queues and reliability planning. And that's why the story starts to feel complicated. Big tech wants compute freedom. Guaranteed power, guaranteed uptime, minimal waiting. Guaranteed uptime means machines must keep running. Communities and regulators focus on nuclear safety. They also worry about grid strain and resilience under scarcity when the system is stressed. A single headline can't decide who should get power first. But we can test it practically, where costs and risks end up. Do the costs stay with the company or drift onto the public system? That's why this becomes a public story, not just a procurement detail. So the goal isn't to argue for or against nuclear. The goal is to test the story, like infrastructure, bottleneck, burden, reality. Here's the simple 3-step check. Step 1 is bottleneck mapping. Where is the constraint, generation, transmission, or approvals? Generation can be the bottleneck. Transmission and interconnection can be the bottleneck. Or approvals can be the bottleneck. In plain terms, the constraint is either supply, delivery, or time. Step 2 is burden tracing. Who pays for upgrades and who takes the risk? Sometimes the company carries the burden through contracts and private investment. Sometimes the grid and the community carry it through upgrades and construction. Sometimes the burden shows up as reliability trade-offs. Step 3 is reality checking. How real is the project beyond the headlines? Start with funding. Is money actually committed? Then permits. Can it legally and practically move forward? And the timeline. Is it a real plan or a vague promise? Put together, that's why nuclear gets pushed to the front of the conversation. And it becomes a public story because it can affect public costs and public reliability. If you remember only one thing, remember this. AI is becoming a power planning problem. And the first question to ask isn't how many GPUs, but how many megawatts? And that's the lens we'll use. Bottleneck, burden, reality. Next time you see a nuclear headline tied to AI, you'll know what to check first. Because in the AI era, power is not background, it's strategy. Now, let's apply the same lens to other AI power headlines you'll see this year. First, ask where the bottleneck is, generation, grid, or approvals. Second, trace the burden. Who funds upgrades and who bears the downside? Third, reality check. Funding, permits, and timeline. Those 3 questions don't judge who deserves power, they reveal who is paying and how constrained the system is. That's why nuclear shows up. It's one of the few sources that can deliver steady, high-density power. But showing up isn't solving. It's a candidate with conditions. For viewers, the win is clarity. You can separate hype from infrastructure reality. And once you see it this way, you'll notice a pattern. AI expands in megawatts first. Because compute isn't just chips, it's electricity, cooling, and the ability to deliver both reliably. In other words, AI has started negotiating with the real world, and that negotiation affects people outside the tech bubble. So if you want to follow AI honestly, follow the power story. And when you do, the headlines stop feeling random. You'll see the constraint, the burden, and the reality signals. And you'll understand why nuclear keeps returning to the front page. Not because it's trendy, but because the grid is tight. And tight grids make every big new load a public conversation. So keep the 3-step check handy. Bottleneck, burden, reality. That's a ComTech way. Less noise, more structure. If you want, I can do a follow-up episode. How 100 megawatts changes timelines and choices. Until then, the next time you read an AI energy headline, you'll know what it really means. Because power is no longer background, it's strategy.